Welcome to qnawire.
So here, the gravity on Moon is only 1/6 the gravity on Earth. So if we can say velocity final squared equals velocity initial squared plus 2 times g, the gravity on either planet, whatever it may be, times delta y, we can say that delta y will then equal negative v initial squared divided by 2g. And as you can see, the final velocity, of course, equals 0 because at the peak of its height, any object's velocity is going to be equal to 0. And so we can say that delta y is going to be inversely proportional to 1 over g. We can then set up an equation and say that if essentially delta y on Earth divided by delta y on the Moon, this will equal the gravity on the Moon divided by the gravity on Earth. This is going to equal 1/6 the gravity on Earth divided by the gravity on Earth. This will equal 1 over 6. And as you can see here, if we solve for the delta y on the Moon, we can say that, well, let's start here. Delta y on the Moon will then be equal to 6 times the delta y on Earth. So you basically have to set up an equation, find the proportionality of the y max and gravity, and then you can set up an equation with gravity because we know that the velocity initial is going to be the same on both planetary bodies. So we can say that if we just substitute in the gravity on the Moon, which is again 1/6 the gravity on Earth, and solve for delta y on the Moon, we find that delta y on the Moon is 6 times delta y on Earth. Therefore, the height on the Moon would be 6 times the height on Earth. So in this case, the maximum height increases by a factor of 6 because the gravity on the Moon is decreased by a factor of 6 relative to the gravity on Earth. The solution. Thank you for watching.